Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host, Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a good bud to the universe. I'm recording from my office here at Pale Blue Podiversity, and I'm expecting a very special guest soon. I'm going to be joined by Bijou Kabeya, a comedian that I met at a show in New York City. I had a great time, and then we chatted afterwards, and she's curious about Newton, Isaac Newton, and his laws of motion. So she should be here any minute now. Bijou, welcome. Come on in.
Yay! Physics. Thank you.
Oh, it's good to have you. How you doing?
I am doing good and I'm nervous. I know physics
Nervous.
is important, but yeah, because this is bringing childhood memories. It's like, oh, physics. But I'm excited to learn about Newton.
Good, good. I'm excited for you to learn too because I had some, bad teacher experiences in my own middle and high school years. I know a lot of people have that impression because they had a bad physics teacher. So hopefully we can kind of wash that physics memory away
Hmm.
and give you some new concepts to grasp onto.
Hey, I like that. New
Hmm.
concept, yeah. I'm sure it's
Hmm.
important.
Yeah, it is
Yeah.
important, but we're here just to chat. There's no test. I'm not gonna quiz you on what you know or remember or
Oh,
anything.
good.
So,
I know E equal MC square. That's not Newton. That's like Einstein guy, right?
yeah, that is Einstein.
Yeah.
But, they both worked on gravity, so it's
Cool,
similar.
cool.
Is there anything you would really want to know about Newton and his laws of motion by the end of the episode?
Yeah, I would like to have it make sense in daily living because when I was learning physics, everything always seems outside everyday living,
Mm-hmm.
and except for like gravity, which we just threw something and then we like, oh, that's gravity, yeah. But Newton, yeah, I get it. Something pushed something and it moves, or something's at rest. But I never see like how you use it. Like I'm
Mm.
not gonna be throwing a stone, when I'm a kid. I mean, I just never saw how everything connected.
Okay. Yeah, some real life practical applications.
Yes. Yes.
Perfect. Okay,
Yeah.
yeah. Yeah, we'll get to that for sure. I'm going to dive into Newton's early life and the schooling that he did and all of the big publications that he gave us, including the one that gave us his three laws of motion. But before we get to that and before we answer some of your questions about Newton, I am trying to get to know all of the students here at the Podiversity a bit better. So I have this
Okay.
personality questionnaire just to understand a bit more about who you
Yes,
are.
yes.
Great.
Good, good. Yes. I would like to understand myself too.
I mean, if that isn't the meaning of life, then I don't know
I
what
mean,
is.
I feel like when someone asks you about yourself, something also about yourself clicks in. You're like, oh yeah, yeah. So it's good.
When you teach someone science, that's the best way to learn it yourself because you are like re-articulating it in whatever way makes most sense to you. And I guess it also goes for when you're telling someone about yourself. Then let's get to it. Question number one is, how does thinking about the universe and all of space out there make you feel?
Oh gosh, it makes me feel small.
Mm.
And it also reminds me of growing up in Africa because I grew up in Congo.
Hmm.
And I remember I really have this vivid memory of looking at the sky at night. And the sky at night, when you have no electricity in Kinshasa, was the most beautiful sky that I haven't seen yet. I know when I go back to Africa, I do see it because we're under the equator. So you get to see, it's like when it's 6 o'clock, it goes dark right away
Ooh.
because we're under the equinox. And so when I think about that, when I think of the universe, the first memory that I have is of myself. Like I'm 4 years old, I'm Kinshasa, there's no electricity, and I see a moon and I see the stars. And then I asked my cousin, she says, like, that's the star, that's the universe. I felt so small and overwhelmed that I remember crying because
Oh.
she says to me, why? Because I said, it's so beautiful that you can capture it.
Oh, that's a good crying.
So I was like, well, why can't we just have this all the time? She said that, well, it's always there. And I lost her because she started telling me about how the earth rotates but the universe, I always feel like so small. Like I feel like it's so big and we're
Hmm.
so small that everything that we fight for, everything, it just seems so banal when you think of the universe.
Mm.
Because and we're still discovering it's something that is not finite. It's still growing and we're still learning.
Yeah.
It humbles me a little bit, yeah.
Yeah, I feel that too. When I look up and I'm in a really dark sky location, I feel very small, but protected by the big thing around me. When you feel small, is it I'm small and scared, or I'm small and there's something big looking over me?
For me, it was both small and scared, but
Mm,
also small and not able to understand this idea of existing in a vast universe.
yeah.
Because it's like, what do I belong in a timeline like that? My brain always wants something concrete. But when I think of the universe, I don't feel concrete. I feel like I'm part of this particles wondering, and I always feel like that I don't feel, I don't know. I'm interested in seeing how you
Mhm.
feel, but I feel like I'm scattered and there's just all
Ooh,
these pieces.
yeah,
Yeah.
that's so interesting. I haven't thought about it in those words before, but I guess I feel like I'm definitely a part of something bigger that is moving in ways that I don't totally understand. So I feel connected to all of that. And in a way, that's kind of like scattering my consciousness or my awareness across space. But it feels very comforting to me.
Okay, I like that. I want to get to the comfort. I feel because it's like stepping in the same water. You know how they say you cannot step in the same water twice? I feel like when I
Mm,
look at the universe, all this idea of universe, there's always something revealing itself and it's always changing. And
yes.
I'm always terrified about changes. So something was like, well, I want something concrete. And then I realized, well, nothing is really concrete. Like everything around me is changing. Everything is, so when I think of that, I was like, well, am I this
Mm.
person at this particular moment? Am I going to be the same in 1 minute? So my brain is always working like that, like trying to hold on to something.
I can definitely see how that would send you down some long
Yeah.
hallways of thought for sure. Yeah, there's a lot to uncover there, but I think maybe I'll leave you to do more of that self-reflection with
Yes,
the
yes.
universe. Okay, so then my next question on the Get to Know You questionnaire is, do you have a favorite equation in math?
Yes. My favorite equation in math is a squared plus b squared equals c squared. Because I just feel
Ooh.
like, okay, that's it. I remember that.
Yeah, it's nice. It's got good shapes to it. A triangle
Yeah.
appears so many times in our lives, and so this
Yes.
Pythagorean theorem is really useful.
Yes. Yeah. Yeah.
Um, do you feel like your sun sign, your zodiac sign, fits who you are as a person?
Taurus.
Mm,
Oh, yeah. Yes and no. People say I'm an earth sign. I'm supposed to be loyal and stubborn, but I don't feel like that. I do feel I'm loyal,
hmm
but at the same time, like they say, like you have to find out what time you were born and what part of the world, and then it becomes too complicated. But I
hmm
can say, does it fit me as a Taurus? I'm definitely very loyal, but the word stubborn, I think I am persistent. I don't think I'm stubborn. I really never thought I'm stubborn. I'm definitely will keep going, and
hmm
I think when I was a child, the idea of keep going, a lot of people interpreted as stubborn and it made me become, it stopped me from moving
mm
forward. And because I didn't like that word stubborn, I knew I wasn't stubborn. I wanted to ask questions. I wanted to explore. I wanted to challenge things. Now, being of African background, you don't really, around adults, you don't ask questions. You basically not to be seen. So I
hmm
remember when I would make like a facial expression, people were like, "Oh, that's a typical Taurus. You're stubborn." And in my head, I was like, "No, that's because you don't have an answer for me."
Yeah.
So I knew that the zodiac was depending on if someone had a bad experience with a particular sign, they automatically be like, "Oh, So I knew something was fake there. I was like,
hmm
that can't be science, can it? I mean,
No, it's
so
not science, and I don't follow it,
exactly.
but so many of my friends like talking about it that I have started to have fun talking about it.
I was like, oh, she's a Taurus. Oh, she's stubborn. Oh, she's an Aries. Oh, she's stubborn, hot-headed. You're like, oh, I just feel like people carry their experience and just project it on someone when they meet. And I
Yeah.
do know some part of the world, like in India, it's a huge deal because I had an Indian friend and they really take that whole horoscope to another level.
Mm-hmm.
businesses, marriages, and everything. But
Mm-hmm. Housing applications.
everything, yeah.
Yeah.
But with me, it's just like, eh, it's a Taurus, yeah.
Yeah. And you're not stubborn. You had grit, you know?
I think so, yeah.
Okay, so the next question, have you ever had an encounter of the third kind? I don't know what the first two kinds of encounters are, but apparently the third kind is
Okay,
with like aliens or UFOs.
well, okay, don't make fun of me, but this whole alien thing, they like I'm from Africa. We always wonder why is it always in America that people see alien and we haven't seen any?
Mm-hmm.
Until I can see in my own country, in my own continent, then I say no. Because I'm just like, they need to come to us too. Why they have to discriminate? I want some aliens in Congo right now.
That's the best answer I've ever heard to this. Yeah, because it really does show you that it's all concentrated in one area because of
Yeah.
like, this idea spreads. It's not that they're seeing things, it's that their ideas are being influenced by stories that other people are telling of alien sightings.
I feel like there is energy of
Mm,
things that we may not see. I don't know if it's human or non-human, but it's just like when you had bacteria and you need a microscope to see it. We had to invent the microscope to see those things that were killing people and all sorts of bacteria. But I feel like with energy or whatever other things, maybe we need to come up with some form of machine or something. Maybe we can see those third. I think it's more energy. I don't
mm,
know what it does, but I don't think we are alone. I think this idea of like the spaceship, I don't think it's like that. I think there probably are things around us, but we can't see it. But
hmm
I think it's there.
Yeah, I love this thread of we need to invent this next machine that's going to let us perceive the world in a different way that we can't right
Yeah.
now. There are definitely all sorts of things that science can't explain. That's why like supernatural and paranormal phenomena keep being observed. That's one of the reasons, right?
Yeah.
And so, yeah, you're right. There are things happening that we can't see that science just hasn't invented the tool to observe yet.
Yeah.
I love that. If you could witness any event in space, like two black holes merging or a planet forming or anything, and you would be completely safe, what would you want to see?
Oh, that thing that I saw in the late 90s. I forgot what it's called in English. Forgive me, English is not my first language. But it was moving across the sky like oh God, what is that called?
Like a comet?
Yes, I want to see a comet where if I could see where it's actually where it began, the
Ooh,
formation of that, that's what I want to see because it's fascinating. It's just moving, and I'm like,
hmm
where did you come from? Like, who let you out? Like, where are your friends? Like,
Yeah,
why are you alone? Where's your mom
yeah.
and dad? I want to see it. What,
Where are your
are you
adults?
running away from home? Like, this is just that's what I thought when I saw it. I'm like, where did this come from? They're like,
Ooh.
it's a comet. But yeah, but where's his mom and dad?
That's a great question. Can I tell you the answer? Like how they
Yeah.
form? So when a star first forms, there's all this debris, all of this gas and dust around it that didn't go into the star. And all of the planets and comets and asteroids or something in a solar system form in that disk of debris. So over time, little tiny pieces of dust collect together, kind of like a snowball falling down a mountain, and they get bigger until they become
Oh,
planets. But some of the smaller chunks, they don't ever get big enough to become planets, so they become comets and asteroids. And sometimes you get a big piece of rock that's almost a planet, and it like something hits it, and it gets blown up, and then a bunch of little comets are formed. So they form both from things breaking and things clumping together.
oh, they're just like leftovers. Oh, that's good.
They are leftovers, yeah, and they orbit the sun just like the planets do.
Yeah, they're just like, oh, we're not big enough to make it through. We'll just stick here.
Yeah. Yeah, we'll just fly by every once in a
We'll
while.
just
You
fly
can make a
by
wish
once in
on
a
us.
while. Yeah, well, you can pop by there. Yeah, okay,
hmm
that's good.
hmm well, if you would like to go visit them, if you wanted to go to,
Yeah.
say, the asteroid belt between Mars and Jupiter, imagine you're being launched off of Earth to the
hmm
asteroid belt. What music, what song would you want playing as you blast off?
Oh God, I want disco music. Because I feel
Yes.
like circa 1975 to 1979, just,
Hmm.
random Studio 54 music. And so this way I'm not conscious, like, I'm just like, feel like it's a party and I get to look at things. Yeah, a good party, like a good 70 music will be
Okay.
definitely.
Just so put a
Yeah.
playlist on shuffle. Oh, I love that. We will also make sure that your spaceship, that your rocket has a disco ball in the pilot capsule.
That makes sense. Like, yes, glam rock, just like everything, just the whole thing. I'm just sitting there being fabulous with nice long lashes, my hair part like Charlie Angels, just oh.
Yes. Yes. Face beat, like you're good. You're
Basically
stunning.
just like, yes, where are you, Comet? I'm here.
Perfect. Well, Bijou, I feel like I know you much better now, and I'm so glad that you're part of the podiversity.
Oh, good.
Okay, those are all the questions I had for you. I would love to address some of your questions about Newton now. And if anything comes up, feel free to
Oh,
ask.
okay. So when I think of Newton, I remember force equal ma, which is mass and acceleration.
Yes, that's one of the
Yeah,
laws.
yeah, that's what I remember.
Hmm.
And Newton, was he Scottish?
He was English.
English. Okay. Well, I
Mhm.
remember reading about him, and this was a big deal. I remember he wasn't killed like the other guy who discovered
Correct.
was Galileo. They didn't kill him. But he was born at a nice time where science started making sense,
Hmm.
like people recognized the Earth was round. So that's pretty lucky, and he became a Sir. So that's pretty good. Good for
Yes.
Newton. Um, I know that everybody in quantum physics, all this self-help, use Newton's third law.
Oh,
Every
do they?
action, there's a react. Oh yes, oh yeah, that's karma. Oh God,
Mm.
Newton's third law has been abused in the self-help world.
I didn't know. Oh, poor Newton.
The law of action and reaction. This law states for every action, there's an equal and opposite reaction. Now, anybody who's been done wrong will name that Newton law just to make sure you get your karma too.
Hmm.
Like, let's say you had a breakup, you tell your ex, whatever you done to me has been done to you, like the color purple here.
Hmm. Yeah, it's just gonna. It's the
Yeah.
I'm rubber,
So,
you're glue.
yes.
Whatever.
So that's the third law. I see that a lot. But the one thing that I don't understand is Newton's first law. That
Mm.
inertia thing, like, if an object is at rest and remains at rest and something rolls it and an external force. But why we have to learn that though? That's
Mm.
obvious. Something was sitting there and then he put
Yes.
another rock. Hey, that's when Newton really discovered, he goes like, this is my first law.
Mm.
You're like, ta-da!
I'm taking notes. I'm taking a note because I want to come back to that point. Like you're right. The first law is pretty obvious. Why did it need to be said? But the reason, I'll just address it now actually. The
Yeah.
reason the first law of inertia, which I'll get to later in the episode, had to be stated was because there was this idea at the time that objects could behave based on their natural affinities, that
Oh.
objects might want to move on their own, or that they were designed by the creator with the ability to move on their own, not consciously, but like the idea was that the planets always want to be moving towards the sun. And it's not that there is a force from the sun pulling the planets in, but that the planets innately want to be near the sun, so they will move on their own.
Oh, okay. Okay, so good for you. Okay, that makes sense. Okay.
Okay, good, good. We cleared that up. Yay. Um, I want to start with Newton's like early life so that you have some context for what was going on when he was doing this
He
work.
was lonely, wasn't he?
I think so. I think he was. He did have a year later on in his life in the 1700s that people call his dark year when he was really depressed and he didn't do any work and he just kind of stayed at home, which is like so relatable. But that was the apparently an outlier in his life. The rest wasn't like that, but he was one of those old world geniuses. I'm sure he was tortured in his way.
Yeah.
He was born on Christmas Day in 1642, but the calendars were changed in 1752, and things got jostled around. So, according to today's calendar, he was born on January 4th, 1643, but, around the turn of that year. And he died in March in 1727, all of that in England. I don't know if he ever left the country.
Wow, that's a pretty long life being back there, that he managed not to die or, it's like all those weird diseases.
What is it they say? An apple a day keeps the doctor away. He
Doctor
had a good
away, yeah.
relationship with apples.
Yes, he did. Newton's apple. Yes, a lot of apple stories with Newton's. I remember that too. Yeah.
Yes, yeah. So he was born in 1642 or 1643. His father was also named Isaac Newton and was a farmer, but his father died a few months before he was born. So Isaac Newton and his mom lived together on the farm for a little bit until his mom remarried when he was pretty young, and she didn't take Isaac with her. She sent Isaac to live with her mother, so his grandma, and then she got remarried.
I'm sorry, that's funny because he's like, no, the man was like, I'm not raising someone else's baby. That's
Literally.
what he was. Like, I'm not, don't bring him. And she's probably like, well, don't have a job. I need to depend on the man. Okay, Isaac, you gotta go live with other people.
That's literally what happened. And then she had 3 more children with her second husband. Meanwhile, Isaac started going to school when he was 12. It was a boys' school where he studied Latin, ancient Greek, and some mathematics, or some maths, as people say across the Atlantic. And when he was 17, his stepdad died. His mom's second husband died. So his mom pulled him out of school and went back to the farm where he was born and told Isaac to work as a farmer. And he was miserable. He was not having it. He was like, I don't know what I want to study, but I want to work with my brain and not with my hands and the rest of my body. Mm-hmm. So she let him go back to school after the headmaster of his school was like, no, he should really return to his studies. And he excelled. He went to study at Cambridge at Trinity College, because to Cambridge people, that matters. So at Trinity College in 1661. So he's like 18 or 19. He studied math, optics, physics, and astronomy eventually. Those were some of the electives that he took, or some of the other things he was interested in studying. But he was mandated by the university to study things like Aristotelian rhetoric and logic and debate. So they had to know how to speak and write. And the Aristotelian influence didn't stop there. So they would teach Aristotle's version of the universe, which was geocentric. At the time, Cambridge taught that Earth was at the center of the universe. But Newton started to read more modern works by scientists like Galileo, who had just been put on house arrest a decade earlier by the Catholic Church. And Galileo actually had died almost exactly a year before Isaac Newton was born. But he was also reading Kepler and Descartes and all of these philosophers and mathematicians of the time. He got his bachelor's of arts in 1665. He graduated, and then a couple months later, the university closed because of the plague. Have you heard of this? Not the plague, but the Isaac Newton's connection to the plague.
No. When I was learning Isaac, we were just talking about what he invented, that he was using the telescope and all the optics, but not anything of his personal life. It was more about school accomplishments and what influenced him, like Descartes, like you were saying, but nothing about his personal life, like he was in a farm now. Not at all.
Okay, that makes sense. I remember when COVID hit and everyone left their university offices and started working at home, there was this story going around about how when Isaac Newton was in school and the plague hit and he had to go home, he had his most productive years ever. And I really hated that story because I just wanted to sit in my pajamas and cry.
At home?
At home, yeah. And not be expected to, produce some great scientific magnum opus.
Yeah.
But that story did circulate.
Oh, so you felt pressured, huh?
For sure. And it was one of my most professionally productive years. But also it was just a terrible time. So I think academics around the world can sympathize or empathize with Newton a little bit more now. So the bubonic plague hit London in 1665, and Cambridge shut down out of precaution. Newton returned home to the farm, and some people consider the next 2 years his, not just his, but the two most productive years any scientist has ever had. He did his prism experiments where he let sunlight shine through a prism and he showed that it split up into different colors. He measured the temperatures of those colors and showed that red is cooler than blue. He worked on a mathematical method of fluxions, Fluxion. A fluxion was essentially what Isaac Newton called a derivative. Did you get into derivatives and calculus in your math classes?
Oh, yeah, yeah. I did poorly. Yep.
Mm-hmm.
And I realized I would never do good in the market because that word derivative during the 2008 crash was used a lot and no one could
Everywhere.
explain it. They're like, derivative, derivative, derivative.
They couldn't
No
tell
one
you.
could actually explain. They couldn't tell me, but I know it was something important that no one could say, and if, could never actually explain to you. I just knew it was complicated.
Hmm. Yeah, a derivative, put simply, is how you can calculate how something has changed over time. It can be your position over time. It can be your weight over time, the number of books you've read over time. But the
Oh,
derivative is like between time A and B, how many have you read? It's really
uh,
simple. And so he came up with this idea of fluxions, and that was essentially the foundation of calculus. But he didn't publish his work until much, much later. So there was actually this kind of like beef between him and a German mathematician named Gottfried Leibniz, who claimed to have created calculus first. But there was an academic battle of wits, and the Royal Society or the Royal Scientific Society or something, they did eventually determine that Newton created calculus first.
yeah.
So he eventually won.
Oh, wow.
This is all in that 1 year still. The reason he didn't publish it until much later was because he had a hard time finding someone who would publish his giant treatise on calculus. And so he switched to a type of math that was apparently more popular at the time, algebra.
Yes, I like algebra. I feel like
Hmm.
I understand it.
Mm.
That
Hmm.
tells you how much my math is. Algebra is like
No,
basic.
it's more
It's
intuitive.
true. Because, you can give example of algebra using money, and I understand money.
Hmm. Good. I don't really understand money.
Derivative is really hard to explain with like that's why that's why the market crashed. No one could explain derivative with money.
Hmm.
Still don't know what happened.
Weird.
Mm.
Weird. No, they're trying to make it sound extra complicated so that people don't see how terribly fucked up. That's really what it is.
That is so true. It's
Yeah.
like using big words and complicate people. I like that.
Mm-hmm. That's like trick number 3 in the playbook.
Yeah, make it
Yeah.
complicated. Well, yeah,
Hmm.
okay.
That same year, or that same couple of years, he also started pondering gravity. He had been reading Kepler's work. Kepler, in the decades before, had been studying the motion of planets around the either Earth or the sun. They weren't sure which the planets orbited then, but he did come up with some laws of planetary motion. And he wasn't the only one. There were a bunch of other people at the time who were coming up with ideas for how planets' orbits worked. But Newton wanted to explain why. Like, what was the physics and science that explained why the planets moved the way they did? Because Kepler had figured out how the planets move. Newton wanted to figure out why. So he started doing that in that same year. And then he returned to Cambridge. After they reopened from the plague, he returned to Cambridge and he became a professor of mathematics. With his appointment, he also had to teach geology, and he made significant contributions to the field of geology. Before, it was not super scientific, and he really sciencified it by incorporating more math and more rigorous observation, which was interesting. I didn't know he was related to geology at all. He also continued his optics and his gravity studies, and he got into both alchemy and theology. Theology was because there was a requirement at Trinity College that if he was going to be a professor in that position, he had to do some sort of religious studies and also religious commitments. Like he had to sign some pledge that he believed in a particular Anglican Orthodox doctrine.
Might cut his head off, so he had to.
Right. Yeah. He was like, oh, I don't want to die. I just do my math.
The church was very powerful back then, so.
They really were. I mean, they still are, but not as.
They still are. No,
Yeah.
yeah.
So he was teaching there for a long time, 15, 20 years. He published the big work that he's known for, Principia, which gave us his laws of motion for the first time in 1687, but there were other editions after that. He left Cambridge in 1695, so 8 years after he published Principia, because he was just like kind of mad at the university and how they were handling things and what they made him do. So he left to go to London and he continued his research. He became the Master of the Mint in England for some reason, and also published a whole treatise on optics in 1704. And the year after that, he was knighted. He became Sir. So he had a long, busy life, for sure.
I like it. I mean, he got to do what he loved.
He did.
And not stay in the farm. Yeah, that's a pretty good life.
Yeah. For some people, farming is their North Star. Newton was not one of those people. Hey there, fellow friends of the universe. Bijou is looking for the hidden door in my office that leads to my secret lab space, so I figured now would be a good opportunity to share some messages with you. The first message is a big thank you to all of my patrons. I really couldn't make this show without you because I am an independent podcast. So thank you all for your help. And I want to give a huge special shout out to my sun-like stars, Scott Reynolds, Augustine, Tom T, Mark Mahoney, and Nicole Bartlett. You're golden and beautiful, and thank you so much. If you want to support this indie podcast on Patreon, you can hear your name on the show, make it onto my patron star chart, and get research notes for most episodes for just $5 a month at patreon.com/palebluepod. That link is also in this episode's description. And if you can't support the show financially, that's okay. I understand. The best way to help the show is actually to get everyone in your life to listen to it too. Make Pale Blue Pod a group activity and help more people befriend the universe. And I would really appreciate it. Thank you. All right, I have a podcast recommendation for you. It's another show in the Multitude Collective, and it's called Big Game Hunger. I've been on this show. It's super fun. It's a weekly comedy show where Jenna Stieber and friends craft the next big video game every single episode. Starting with a randomly generated genre, concept, and vibe, Jenna and a variety of funny and game-obsessed guests will take these ideas far enough that they could totally pitch it to a shadowy board of rich investors. And by the end of the episode, they will have honed an intellectual property so irresistible that you would be ready to risk $25 for it on Steam. But don't worry, they will surely never make their release date. So get ready to laugh about games you love and learn about game trends with Big Game Hunger. New episodes come out every Monday. Ooh, Bijou found the secret door! We're going to explore that lab later, but for now, let's get back to Newton. And so he obviously has this long legacy of being a genius scientific mind, calculus, geology, apparently, algebra, everything. Everything has influence from Newton. But we are here to talk about specifically his laws of motion, his laws of gravitational motion from the Philosophiae Naturalis Principia Mathematica, or the mathematical principles of natural philosophy, which, like I said, he first published in 1687, but he published 2 more editions of it with updates each time. And the third and final edition was published in 1726, which is almost 40 years after he published the first one. So that, I think, should give us some comfort. Like, he made updates each time. It wasn't like he said this once and then just left it there. He went back to it. He spent decades of his life making sure that the Principia was correct.
Good.
He was basing his work off of previous work looking at the orbits of planets, right? So Kepler, but also a bunch of other people at the time who had their own ideas. And he starts Principia with a bunch of different definitions for quantities of space, time, and motion, like mass, which he defines as a quantity of matter and a measure of matter that arises from its density and volume jointly. I don't think that's a very useful definition these days, but that's the type of definition that he was including in his paper. He also mentioned inertia and centripetal force, and he defined those. And he emphasized that a force has both a magnitude and a direction. That was important because at the time, people were treating the idea of force, like this centripetal force, as an object in itself. The force was a thing that you could point at. And Newton comes along and he says, no, forces aren't things. Forces are quantities. And you have to study them in both their strength and the direction that they're acting in. Today, in science, we would call this a vector. A vector has both magnitude and direction.
Okay.
And then the paper is long. The translation of the paper that I found, it's a book. It's a book. It's hundreds of pages. I don't know if people realize that, but Principia is very long. And there's like one page that has all of the laws on it. And that's the page that most people pay attention to. So the first law is the law of inertia, which you said was the one that's the least clear to you.
Yeah, it's like something, like something is at rest, and it will remain at rest unless something by force or something touches it, then it moves.
Yes.
And I was just like, okay, why do I need to learn this? Because you
Yeah.
see that all the time, but you don't know that's Newton's first law. I'm sure kids, when they're playing and something moves, they're not going to automatically go like, oh, that's Newton's first law. That's why. I'm just like, okay, that happens. And
Right.
yeah, and then there's velocity involved, and you're like, great, so if you roll something really fast, then the other one will also the object at rest will also move a little further.
Mm-hmm.
Okay.
I think you remember a lot more of physics than you let on at the beginning, Bijou.
But I remember the experiments. Have a little green ball and a little red one. You'd be like, oh,
hmm
move it fast. And then you'd be sitting there, you'd be like, look at my partner. Yeah, we did that. Now what? That's what I
Yeah.
remember. I remember
Yeah.
looking around and trying to sound profound, like, oh gosh, yeah, this is really important. And then my brain is like, yeah, but why? Why are we doing this?
Mm.
Why is it so important?
Yeah, the first law, Newton's first law, like I said before, it's very obvious now, but back then was kind of a bit novel. It was making a statement that not everyone at the time would have agreed with or believed. So that's why it seems so simple to us. But I think this is interesting because I usually, and most people do, usually think of Newton as having studied gravity, right? I associate his laws with gravity, but they actually apply to other forces, friction forces or tension forces or spring forces or anything like that applies here too. So the way that he initially said the inertia rule, the law of inertia, was that everybody perseveres in its state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by forces impressed, which is the very fancy 1600s way of saying an object at rest tends to stay at rest unless it's acted upon by some outward force. This has all sorts of implications, and it's like everywhere in our lives. When you're driving in a car and someone hits the brakes and you move forward, that's inertia. It's because you were already in motion, so your body stayed in motion until there was a force, the seatbelt, that acted on you to keep you in place or to stop you. This is when we launch rockets up into space. The reason that rocket needs to be so powerful is because it needs to overcome the inertia being here resting on Earth, and then like getting to the high velocities that it needs to escape Earth's atmosphere. I think of this also in my personal life in a non-scientific way. I describe myself as a high inertia person, which is my way of saying I have ADHD.
Oh, me too.
Yeah.
And you seem to do very well. I mean, you're a physicist, doctor. I don't know. I can still fix my room, so I don't know. Like that is amazing. Like your ADHD in physics? That's amazing.
It's the combo of ADHD and spite that's given me
Oh,
this.
okay, cool.
But okay, so someone else with ADHD, maybe this resonates with you. If I'm sitting on the couch, I'm done. I'm done for the
Yeah,
day.
me
It's
too.
going to
Yeah.
be impossible for me to get up there. But if I'm out and I'm moving, if I'm like cleaning and organizing and doing all that stuff, then I'm gonna keep going until something stops
Yeah.
me. Yeah.
Oh, okay. Oh, that's good to use in it.
Yeah, that's
Inertia.
inertia.
So
Hmm.
can I ask you something about this inertia thing? So like the
Hmm.
Earth, right, is moving, orbiting the sun, right?
Hmm.
So even though it's moving, is that is to explain inertia, is it like when the Earth is moving, we still feel like we're at rest? Is that what it is? Because I don't feel like I'm moving, but I know it's moving.
Oh, that is actually because of the second law.
Oh, never. Okay. All right.
No, but
But
you're
I
you're
always
on a
want,
good
yeah.
path.
Oh, okay. And I'm
Yeah.
just like, yeah, I know it's moving, but I don't
Yeah,
think all of us wake up and go like, "Oh, do you feel the motion of the earth?" No, but we know that. So that means we are also moving, but we don't seem to feel like we're moving.
correct.
So if there is an outside object for the planet, eat the earth, would that impact the movement?
Yeah, that's a good question. So to take it to the space context, the law of inertia says that Earth is going to continue moving on its current orbit until something else knocks it out of that orbit. So, several billion years ago, there was a Mars-sized planet called Theia that impacted Earth. It hit Earth, and our orbit almost certainly was changed a little bit by that. Did you hear about the DART project, the DART mission?
No,
This was
no.
a mission to see if we could divert an asteroid that was coming to Earth. This asteroid was actually not on an impact collision course, but we wanted to test out the technology to basically push the asteroid a little bit off of its orbit so that it didn't hit us. And it was successful. Just so we're all clear, it was very successful, but that is inertia. We needed to exert a force on that asteroid to make it change its trajectory. Otherwise, it was going to keep moving in that same direction.
Okay, that's good. That's good. So we kind of avoided incidents and things like that. Okay,
Hmm.
cool, cool. All right.
Yeah. Moving on to the second law, I'll be able to explain why we don't feel like we're moving here on Earth.
Yeah, that is one of the things that used to get me really upset in school. Because
Mm,
every time someone
hmm.
says the earth is moving, I'll be like, nope, I'm still standing.
Right. Yeah, I
I
don't
don't
feel it.
know. Okay, so second law, force equal mass and acceleration.
Yes. So F equals ma, one of the most famous equations in science. The way Newton put it in the Principia is that the alteration of motion is ever proportional to the motive force impressed and is made in the direction of the right line in which that force is impressed. This was actually quite exciting to equate all of these things. He was not the first person to do this. He saw the F equals ma equation in a different paper that was published after the first edition of the Principia. So that he's actually kind of borrowing from other scientists at this point. But F equals ma is useful in all contexts, in like so many different situations. The reason we don't feel like we're moving here on Earth is because we're not accelerating. So the only time you would feel a force is if you're accelerating, which means if your velocity is changing. So here on Earth, the Earth's velocity is constant. So we are not accelerating, so we don't feel a force from our motion. When you're driving in a car, if the car is driving at a constant speed, you don't feel like you're moving.
Yeah.
But when the car slows down or speeds up, that's when you feel a force. And that's because you're accelerating.
Okay. That
Does
makes
that make
sense.
sense?
So my question, so the force and the momentum affects that? If something is like you say we're moving, right? And then we apply the
Hmm.
force. Now, the force will include speed to it. Would that impact change is it
Mm.
force just force or is it force and velocity or speed or something that will also give different results?
Hmm. Yeah, so these are all separate quantities.
Okay.
There's the force,
Yeah.
which is like how much were you pushed on or how much were you pulled
Okay.
on. Then there's the mass. What is your mass? And then there's the acceleration. How much is your velocity changed over time? Going back to some calculus,
Yeah.
acceleration is the derivative, the time derivative of velocity. So acceleration is how much your velocity changes over time. And this equation isn't giving like a direction of influence. It's saying all of them. It's saying that they are all connected. If you apply a force, then acceleration or deceleration will happen. If you are accelerating or decelerating, then there is a force being applied and you will feel it.
Okay. I'm trying to picture like something very simple in my head. If you apply force, like I was saying, on a little piece of like a toy or something, but as you're applying the force, like if I'm throwing something, right? Like I'm applying something, so there
Mhm.
is automatically speed involved too, depending on how I'm throwing it, right? They're
They are
related.
related.
Yeah.
If you throw with more force, then the thing will move with more speed. But it's not like they are separate units. They are separate but related.
Separate but related. Okay.
Like
All right.
one influences the other, but they are not the same thing, so they have to be measured separately.
Okay. All right,
Mhm.
Newton's second law. Okay.
Um, Newton's third law is the equal and opposite
Yeah,
reaction
karma.
law, which
Telling
apparently
you.
has been used in self-help. I didn't know.
Google it, like watch Medea, you're gonna hear that. Oh, whatever you done to me is gonna come back to you the same way. That's the definition of karma. It's as
Yeah.
you reap, you sow. That's the same thing as Newton's third law. Whatever you do in the Bible,
hmm
they also say that whatever you do, it shall be done unto you.
Right. Yeah. I mean,
Now, I'm just wondering, did Newton use this? Because he went to Trinity College. I'm just telling you, what he wrote here, if a person who doesn't believe in science only believes in Christ would be like, yeah, that's what Jesus said.
hmm Yeah, you can definitely see the parallels. But there are a lot of scientific phenomena that get co-opted into kind of psychological self-help things, but I didn't know about this one. So yes, for every action there is an equal and opposite reaction. Newton said, to every action there is always opposed an equal reaction, or the mutual actions of two bodies upon each other are always equal and directed to contrary parts. He also said, if you press a stone with your finger, the finger is also pressed by the stone, which is just, it feels very, very proverby to me, and I like that. But this is why it hurts when you punch something, right? Because when you
Yeah.
punch something, you are exerting a force on the wall, but the wall is also exerting a force on you. I have a very dumb cat, and anyone who's ever seen a cat like start to run from a sitting position. Cosmo, my cat, often likes to sit on my books or my computer or my notebook or something. And then he'll get startled, so he'll run away real quick. And when he does that, his back paws will push off the notebook and he'll propel forward and the notebook will move backwards, right? That is the
Backwards.
equal and
Yeah.
opposite reaction there in real time. There are lots of other real world examples of this for sure.
Karma.
Karma, there you go.
I'm telling you, karma is Newton's third law. Just
I'm sure that people have made that connection because it does make a lot of sense if you're not thinking about it, like quantifiably. So those are three laws that Newton gave us. There is a secret fourth law. People talk about the three laws, but
wait.
there's another one.
There's a fourth law?
There is a fourth law. I actually think that it should go before the others, so I call it his zeroth law, and it's the law of universal gravitational attraction. I think that when I explain it, it will sound kind of familiar, and it is, in my mind, very similar to the third law. It does seem kind of along the same theme of equal and opposite reaction. But this zeroth law is his law of universal gravitational attraction, and it says that any two bodies are attracted by a force proportional to their mass and inversely proportional to their separation squared. So if you have two bodies that have mass, they are both going to exert exert a gravitational force on each other, and the strength of that force will decrease as the distance between them increases. So as the bodies move farther away, the gravity between them is weaker.
That makes sense. So this has to do with the force of the is it like attraction or something with the two bodies or no?
It seems to be a very specific instance of the equal and opposite thing.
Okay.
It's only
Okay.
talking about gravitational forces, whereas the other laws are for any type of force. But this is where we get the equation for the force due to gravity between like a planet and a star, for example, that a lot of astronomers will
Oh.
use to do any sort of orbital calculation.
Oh. Okay. I did not know about Newton universal gravitation law. I'm not gonna lie to you. That is.
Yeah, they skipped right over it. And that was actually one of the more controversial parts of Principia. That was the part that other scientists at the time had a harder time accepting because they were like, what do you
Wow.
mean? The moon doesn't pull on the Earth. The Earth only pulls on the moon.
So the moon pulls on the Earth.
Exactly. Yeah.
Yeah.
We technically exert a tiny gravitational influence over the
Oh,
Earth.
really?
Yeah,
Oh,
yeah,
I didn't know that.
every person does. Even like your watch, right? Like everything that has mass has a gravitational connection. But if the mass is really small, then that connection is really weak.
Oh, that's something I
Hmm.
learned today. Everything has a mass and gravitation. Just this
Hmm.
alone was a good thing to learn today.
Good, good.
You should be my physics teacher. I would have loved physics if I had someone like so passionate about it and all these things. I think that makes a big difference when you have a teacher or that can make it fun because physics does not sound fun.
Yeah, it makes a huge difference. The way that you're introduced to something and how you learn it.
Makes a
Yeah,
difference,
for
yeah.
sure. So Newton's laws don't always apply. Sometimes they break down. And that's why Einstein spent so much time trying to understand how gravity works in different contexts, because we could see that Newton's laws didn't perfectly capture how gravity works. So here are the three scenarios where Newton's laws, Newton's physics start to break down. One is when things are moving really, really fast. This is what Einstein's theory of special relativity was all about. When things move near the speed of light, we call these relativistic speeds, then things like space and time, they stop being absolute and they start being relative. And it's interesting that Newton spent so much time defining what an absolute versus mathematical truth is in Principia, because it shows you that if things are relative, if you're not standing on like the same reference frame, that his physics just doesn't work.
Oh, okay.
The next scenario where it stops working is when gravity is really strong. And this is what Einstein's theory of general relativity is all about. When you are near a really strong gravitational well, like if you're near a black hole, then it can actually warp space-time, and Newton's laws just don't account for that. They don't account for that type of complication. And then the third scenario is when things are really small. Newton's ideas do not apply at the quantum scale because for some reason, and we're not totally sure why yet, mechanics at the quantum scale are just different. So that's when we have to stop using Newton's laws and come up with something different.
Okay. Now, this Newton fourth law, like the one you just described, was it like when he was alive, did he talk about that, or it gained more understanding or even curiosity as we started understanding the planets and other things? Because maybe at that time, talking about certain things out there and not being able to actually go there. I mean,
Mm.
if I can go to space, yeah, then the fourth law kind of makes sense, or at least understanding what's happening there. But during its time, even the early part of the century, like, how are you going to
Yeah.
verify things like that?
Yeah, that's a good question. I think that it became more accepted later on in his life. He also published things pretty late in his life. Some of his work wasn't published until after he died, and the conversations continued to happen. So I think probably the law of universal gravitational attraction was easier to accept once we had instruments that could measure things more precisely. How's your head feeling right now? I feel like I just dumped a lot of
Oh no,
physics into it.
you know what? I am fascinated by it because I actually want to do more experiment because I'm just fascinated by everything that I just learned in the way that it's relatable. I like that,
Good.
that it's not scary, and I wish I had this kind of explanation when I was learning. But also I don't blame my teacher. My English was not good back there either, so I think it was very difficult to be at an international school studying in English while French is
Mm,
your first language. So maybe the dictionaries did not do that well of translations.
yeah.
But yeah, I feel like the second law is still one of those things that I just get it, but I'm like, yeah, I'm just gonna accept it. Like I
hmm
don't like the whole force and inertia thing. It's just like,
Yeah.
okay.
That's what I do too.
Yeah, I like it. Yeah.
Great.
I'm in awe by all these things of the Newton laws and his impact. I think I learned more about his impact in other areas besides the laws of motion.
He
Yeah,
did
it
a
made him
lot.
more like extraordinary so that he had other influence in other area of physics and math, not
hmm
just motion. Yeah.
hmm If Newton were alive today, what's something you think he would really like? Like roller
Oh
coasters. I
God,
think he'd really like roller coasters. They weren't invented
I
until
think so too.
1884.
He would have loved to understand the whole concept of internet.
You're so right.
Because, yeah, I mean, wow, you know,
hmm
because it's one of those, even me, I'm always fascinated by it, like I remember watching like shows in this, made in the 60s, about people talking to the screen and like James Bond, and now I'm doing it with you. So it's one of those things that I'm very like, I mean, it's impressive. And I
hmm
think someone in the 60s would not believe seeing us today and being able to do in such a small equipment and
Let
seeing each
alone the
other.
1660s.
Yeah, so that's one of the things that would have blown his mind.
You're so right. Yeah, I love that. All right. Well, Bijou, I've had a great time. Thank you for coming into my
Yeah,
office.
thank you. Thank you for teaching me so much today. I'm the one who's
Yay.
grateful.
Oh, my
Yeah.
pleasure. My pleasure. I'd love for you to brag about yourself for a minute. What are you up to and how can people find you online?
Brag about myself. You can find me online at Bijou Kabeya on Instagram. I'm working on materials that want to connect growing up in Africa and being like an expat like me and still feeling like I don't belong anywhere. Because
Mm-hmm.
here in America, I'm still, because I have an accent and everything, but I'm still seen like perceived as a foreigner. And when I was in Europe, I was also perceived as a foreigner. But now when I go back to Africa, I'm perceived as a foreigner because I've been outside the
Oh.
country for so long. So there is this idea of where do I belong?
Mm-hmm.
Because the first thing someone would say to me in America, where are you from? Right away.
Mm-hmm.
And back home, it's like, but where did you grow up? Even though I was born there
Right.
because of the Western influence. So I'm fascinating of being a foreigner, even though I've lived in like three continents long time, long enough, but
Mm-hmm.
still be seen as like they say in French, étranger, stranger. I'm a
Ooh.
bit good alien. I've been, yeah. I can say I'm the alien that most people.
Oh,
Yeah, so that's what
yeah.
I'm writing,
Oh,
trying to
nice. I would
fine
love to see
tune.
that. Please
Yeah,
post about it when you have show
I will.
dates.
Yes.
Excellent. I will post your Instagram handle down in the show notes. So listeners, go follow that to follow Bijou. This has been so fun. I've had a great time chatting
Thank
with
you.
you.
Yeah, physics is not that scary.
Yay. I'm so glad I learned something. I learned that the third law has been co-opted by self-help communities. So we're all
Mm-hmm.
learning
Karma.
together today.
Karma.
Um, listeners, I hope you also learned some fun, exciting new things today. But even if you didn't, you're still space. Pale Blue Pod is hosted by me, Dr. Moiya McTier, aka the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.